Well, hello there guys. Today we continue talking about hydrogen bonds. These are special dipole-dipole interactions. Alrighty then, let's go to the fun part. You can also call hydrogen bonds H-bonds. They look like this. As said before, H-bonds belong to the dipole-dipole interactions. So hydrogen bonds belong to the dipole-dipole interactions. However, H-bonds are the strongest of all dipole-dipole interactions. Of course, not as strong as covalent bonds or ionic bonds. Now, you can also remember that dipole-dipole interactions are stronger than London dispersion forces. This offers you a great schema to compare the bond strengths of interactions and bonds. And what exactly characterizes a hydrogen bond? Well, it's all in the name. It's about hydrogen. More precisely, we talk of H-bonds if hydrogen is bound to one of the four most electronegative elements. These are fluorine, oxygen, chlorine, and nitrogen. This means that the most common compounds with H-bonds are hydrofluoric acid, water, hydrochloric acid, and ammonia. Here, H-bonds form because the difference between the electronegativity of hydrogen and the four elements is very large. Remember this, it helps you apply this concept. Okay. And what do these differences in electronegativity actually have to do with molecule interactions? Let's take water as an example. How does a dipole form in a water molecule? Due to its low electronegativity, the hydrogen pulls the electrons to its core very weakly. The pull of oxygen on the electrons is much stronger. This creates a stronger negative charge of the molecule on the oxygen. On the other hand, the hydrogen gets a positive partial charge. A dipole forms. However, we don't have just one water molecule, but a whole load of them. And how do the bonds between hydrogen molecules form? All of them also have partial charges. The positive partial charge on the hydrogen of the one molecule is drawn to the negative partial charge of the oxygen. These interactions are the hydrogen bonds. They are attraction forces between the individual molecules, so to speak. So far, so good. And how does this influence substances? On the one hand, substances with hydrogen bonds have higher boiling points. Take the example of water. At a pleasant temperature of 25 degrees, many other substances that weigh just as much as water are already in a gaseous state. The water molecules hold each other together because of the H-bonds. Therefore, it takes more energy to separate them and turn them into gas. H-bonds also play an important role in biochemistry. With proteins, for example, here, the hydrogen bonds within the protein strands cause the amino acid chains to twist. In the picture, the hydrogen bonds are red. The bonds pull the structure together similar to an accordion. In turn, a spiral structure forms. This is called the alpha helix. Now let's do a quick recap of what you should remember of all this. So, the hydrogen bonds are the strongest dipole-dipole interactions. The bonds in quotation marks form due to attraction forces between the partial charges of different molecules. An H-bond can only form if hydrogen is bound to one of the four most electronegative elements: fluorine, oxygen, chloride, and nitrogen. The hydrogen bonds give the molecules a higher boiling point. That's it. Ciao and see you later. Alright, take care.